All right, here we go. We're going to start lesson 7.3, which is an introduction to logarithms. Okay, this is a brand new topic for everyone, so pay attention here. We're going to continue to build on this over the next few lessons and get to really start to apply these to all the exponential situations we've been dealing with in 7.1 and 7.2. Okay, so what exactly is a logarithm? Okay, a logarithm to the base b exponential is defined as such. Okay, so y equals b to the x is equivalent to log base b of y equals x. Okay, so again, sounds confusing, sounds very different. Okay, basically a log is the power to which a number must be raised in order to get another number. So we have to figure out what do we have to raise it to in order to get out what we want. Okay, I found this little trick, and again, you can take it or leave it. A little screenshot there on the left to go back and forth between one form exponential and our logarithmic. Okay, if you see over here, to go in logarithmic form from exponential, you technically just kind of draw an L. It's a stretch, okay, but you do log base 9 of 81 equals 2. Okay, and then the other way, some people say you roll the log, but you draw an E. To go from log to exponential, you start with a base, 8 to the third equals 512. So essentially what we got is this back and forth way to see logs as equivalent to exponentials and vice versa. Okay, so b to the x equals y. All right, and here I'm going to put the y on this side and then do log base b of y equals x. That did not look like an L. Log base b of y equals x. All right, so you can see that is that and that is that. These go back and forth. Okay, so that's essentially what we're going to practice today, just going back and forth from log to exponential, exponential to log. Okay, so here's a couple you guys can try. Okay, the ones on the left are exponential, so what you are going to do is draw your L. Okay, so log base 3, okay, of 9 equals 2. Okay, so the order in which you see those things is the order in which you write them. Okay, same thing down below. Log base x of 9 equals a plus b. All right, now let's try some here on the right side. Logarithmic to exponential. Okay, so you start with the b, the base, which here is 4. Okay, so 4 to the third equals 64. And that is in fact true. And this last one, again, it's all location and where we put things and how we write it. All right, m to the r power equals g. Mr. G. Okay, so back and forth. So how does this apply? All right, so what's the point? Okay, if you're given a log equation, you can evaluate this. Basically, you turn it into an exponential, and then you solve it like the 7.2 part 2 video that you watched before. Okay, get the bases equal, set the exponents equal. Okay, obviously things will get more complicated as we progress with this. What if we can't get the bases the same? All right, that's when we investigate more detailed properties of logs. Okay, but for now, let's take advantage of the more simplistic stuff. Get this down pat, and then we can expand. So here, 8 to the x equals 16. All right, so we can use this equality property, get the bases equal. So 8 I can rewrite as 2 cubed, and that's all to the x. 16 is 2 to the fourth. Okay, laws of exponents tell me to multiply. So that's 2 to the 3x equals 2 to the fourth. So now that my base is equal, now I set my exponents equal. All right, so my problem turns into 3x equals 4. Divide by 3 and we get x equals 4/3. Okay. All right, let's try another one. Okay, log base 9 of 27 equals x. So 9 to the x power equals 27. Okay, 9 and 27 are both bases of 3, so 3 squared is 9 to the x. 27 is 3 to the third. This turns to 3 to the 2x with laws of exponents. Okay, so because my bases are equal, I can drop them and set the exponents equal. That's 3. So I have 2x equals 3, divide by 2, x equals 1.5 or 3 halves, whichever way you want to write it. Okay? So pretty simple. All right, just a continuation. Okay? The last two slides here, okay, talk about the common logarithm. So when you look on your calculators, okay, you see this log button. Okay, what is that? What does it mean? Okay, it's right here. Okay, what does that log button beside the 7 actually do? Okay, well that log button is actually base 10. Okay, so when you just type in log, okay, of a number, it's technically log base 10 right here. Okay, now we don't always have to write that. So if you don't see a base written there, you know that it's 10. Okay, that is the common log. So what we're going to do to progress in the future is, just like we did up here, we have to get the bases equal in order to solve. Okay, there's going to be a change of base formula where we convert everything to base 10. That way we can actually work with it. Okay, so again, that's going to come at a later date, but again, we're going to continue to build and expand upon our basic knowledge of logs today. All right, so again, just practice here. All you're doing is just jamming these on your calculator and seeing, you know, what we get, and then maybe we can make some observations. Log of 10, that equals 1. Okay, would we expect that to equal 1? Okay, and hopefully your answer is yes, because this is log base 10 of 10 equals what? Okay, that's our unknown. So it'd be 10 to the what power equals 10. Well, x has to equal 1. All right, let's try the next one. Log of 20. Okay, we get 1.3 blah, 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 blah. All right, I don't think that can be made into a rational number, so this is irrational. So once again, we have log base 10 of 20 equals x. So this is 10 to the x power equals 20. Well, 20 cannot be rewritten as a base of 10. So like I said before, the log is the power to which a number must be raised in order to get that number. So what is that number? 1.3010299996. All right, not a common one, which is why we use the logarithms. Okay, same with this next one, log of 45. Once again, 45 cannot be written with a base of 10. So 1.6532. And the last one, log of 4/3. Okay, 0.1249. Okay, so obviously these numbers here, okay, log base 10 of 45 equals x, so 10 to the x power equals 45. These numbers are going to be between 1 and 2 for this third one, because if I give 10 squared, that's 100. Okay, 10 to the first is 1, so it has to be between 1 and 2, because 45 is between 10 and 100. You know, we could do the same thing for the last one, but like I said, get good at rewriting logs to exponentials, exponentials to logs using the properties above. This little log trick right here really has helped me and future previous students, I should say, going back and forth. Okay, so any questions with this, bring them to class, and then we'll get into the properties of logs next time.